This video contains a correction to the last two slides on the video with the above title, which is Kerr geodesics number 9 in the series. It provides the correct form of the angular momentum term of a mass freely falling in the equatorial plane of a Kerr black hole. So we'll go now to the second last slide on the original video, and we made this substitution. H was Q plus A m c epsilon. M is the mass of the freely falling object, which I mentioned was an observer in a laboratory. C, the speed of light. Epsilon was the energy parameter, and A was the spin parameter of the black hole, and Q was the substituted term. So you need to see the video first, and then on the second last slide, the correction is down here somewhere, and it's on the last line. That's the correction there. It's going from the second last line to the last line. And I'll just remind us that Q, we chose this solution here for Q, then we had plus AMC epsilon. Epsilon was this business here, that's the energy parameter. And now, next stage was to do some algebra that we did here. Then we factored out the common terms C and M, and we had negative A times square root U. U was the substitution one made for 1 on R. We had them minus times plus and minus. It flips the sign. When we multiply the minus by the plus minus, it becomes minus plus. Okay, so minus here times plus here gives us this negative, and minus here times the lower negative here gives us this lower plus, and so on. And that's the correction is related to this chain flipping of signs. Anyway, so coming back here, we have plus A times square root U over here, minus 2 times A square root U times mu, and we combine those to get the U cubed inside here. You factor out U squared here and then take the square root of it, you get the U here. So you see that they are the same terms, times the factor U. Then we have minus plus, this object on the end here, and again, U squared times U, take the square root of U squared, gives us a U out front, but we have here a square root U. So another way of looking at it is take the square root U, multiply it in there, so you have the square root of U to the power of 4. Square root of that is U squared, so that's how we get this term down here, times the square root of mu. Denominator is not touched in any of this. Next line down, we have the common factor Cm out front, and this minus A times square root U and plus A times square root U cancelled out, so that's gone. So we're left with this second term, the fourth term and the fifth term. First and third have gone. So we have minus plus, and then here we have minus this, minus plus. Okay, so far so good. Now, and here's where the error in the previous video was that I'm now correcting. This minus plus, if we're going to factor that out here, then this minus here needs to be flipped. It needs to become a plus minus. And the reason for that is, if we take minus here, the top sign, minus, and multiply it with positive here, plus 2 in this case, we'll get a negative result, which is great. So that's minus 1 times plus 2, which is minus 2, that's good. Then if we take the lower sign here, plus 1 times minus 2, that also gives us minus 2. And that's where the error was. I didn't put in the plus minus flipped sign here. And that was a mistake. That minus becomes plus minus here if we're going to factor out this minus plus from this whole line. Now, there's no problems here. We can, this minus plus here, they just come out front. We just have to be careful. Just in here, this can't remain just minus or a plus. It has to be a plus minus, so that the top sign minus 1 times plus 2 is minus 2. Plus 1 times minus 2 gives us minus 2. Then it works. Everything's fine. Negative h is the retrograde case. Plus h, which is the angular momentum of the freely falling mass, is the prograde case. And if we go over here, in summary, for a stable circular orbit at some fixed value of u equals 1 on r, the required energy E the energy of the particle, the massive object, is the energy parameter epsilon times mc squared, and the angular momentum h, and can be found analytically by using this. Okay, that must change there. Minus plus times a plus. Well, a minus and a plus gives us the minus, and a plus and a plus gives us a plus, which is what we had before. So, and also here, minus and a plus gives us minus, plus and a minus gives us minus. So consistent, okay, with what we had on the previous slide. And that's it. That's the only correction, the only update.